Hey everybody, this is Larry. This is me clicking on things and hoping that it loads. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Day 17 of the Leetcode Daily Challenge. Hit all the buttons. As I mentioned yesterday, I guess just in case you didn't see it, because there's still a couple of days left, I recommend if you have time, especially over the long weekend, if you're in the US anyway, you might have a long weekend for Martin Luther King Day. Definitely check out yet another contest 9 on DMOJ, DM Online Judge. Actually, what does DM stand for? Anyway, yeah, check that out. Support Josh, one of our regulars and super smart white person. But yeah, anyway, all right. I'm not going to do it as, a long intro like I did yesterday, so let's go. Today we have 2683, neighboring Bitwise XOR. Okay, so there's an array, length n, by computing Bitwise XOR of the adjacent values in a binary array. Okay. For each index in the range 0 and -1, then So we're given a divide, and then true if such an array can exist, or false otherwise. What does that even mean? Otherwise, I and I plus 1. Oh, this is a circular thing, is what this is saying. Well, this part is saying anyway. So, okay. Given an array derived, the existing routed binary array original that can be formed derived. Okay. I think the idea is that, well, I don't know, actually. I don't know. I was going to say the idea is maybe that we try to find a way or some strategy finding a way, but I don't know that's true. So I think the idea that, actually I was kind of doing it yesterday, even though maybe you can argue that that wasn't super necessary. For this one, I don't know if it's true, but I, for now, don't know. So let's, let's spin this out. Actually, I wrote this backwards. So now we're given the derived array. Let's just say we call it D, and then D sub 0 is equal to D, original of 0 and O of 1, right? Something like that. And then right? Okay, so we'll write it out like we were saying yesterday. At least for now, I don't know what the answer is immediately. This feels very one-off. I think one thing that I would say when you look at me kind of writing this is that, yes, this is very confusing looking, but it is a bitwise XOR, right? And what do I mean by that? It's a bitwise operation, right? And of course, I mean, I guess that's in the name, so that's fair. But an idea to think about is that just doing, because it's bitwise, what happens on a bitwise operation something, right? It's that every bit on this operation doesn't affect others, right? Meaning that the digit in the first bit, the least significant bit, doesn't affect the digits in the second least significant bits, right? And that's not always true per se in all operations. Like, for example, 1 plus 1 is equal to 10 in binary. When 1 plus 1 is equal to 10 in binary, then the least significant digit has addition is an operation that does change the more significant digits, right? But in bitwise operation, and particularly bitwise XOR, this does not happen. So what does that mean? That means that we can write out a truth table, right? Or maybe we can write out a truth table. I don't know. My computer's a little bit wonky. But the idea is that now, instead of thinking about like all this range of numbers, you can just think about 4 numbers, right? Or I don't know if it's 4 numbers, but one set of numbers on one bit, because then now it generalizes because they don't affect each other. So instead of thinking about it as one problem with n bits each, you can think about it as n problems with 1 bit each. N problems where you look at 1 bit at a time. Maybe that's a little bit phrasing better. So yeah, okay. So that is definitely something that you have to think about and hear about this, right? And maybe, okay, maybe instead of that, we can loop it back, right? Well, what does this mean for me, right? Hmm. I mean, okay. There's really not that many things you can do, which is kind of like a little awkward because I'm trying to think about like how to build toward the answer, not just the answer, right? Necessarily. And let's say you just take any two numbers and then it becomes do, right? Okay, so what does that mean though, right? And I took out the O1s because, or O sub 1s because they just cancel out, right? Yeah, maybe we can think of it as maybe we could try to find the array. And how would we try to find the array? Well, so we have these formulas, right? Maybe we can just, and I don't know that this works honestly, but we can just solve for O sub 0, say. So what does O of 0 look like, right? So O of 0 would equal to, well, it appears in two places, right? So you have two formulas. You have, so okay, wait, let me actually step back for a second, right? Let's just look at O sub 0, which is really silly to say. So we have two formulas, right? Oops. We have this one. I apparently copy and pasted the wrong one. Don't know why my computer is so slow. I'm actually not running anything right now. Maybe I am. Firefox sometimes gets lost. Anyway, but the idea here is that, the thing is that right now, right, there are three formulas. Oh, sorry, two formulas, obviously. But three variables and two formulas, which is not, that means that it's just not solvable, right? Or at least not by just this. Because we know what d sub 0, because that's the input. We know what d sub 3, because that's the input. And then here, well, we just have three variables on the right side. Oh no. Right. This is definitely a weird one. Well, I mean, I guess there's one thing you can do, right? Which is, this is, I don't know if this is good enough though as a proof. I'm not sure. But the thing is that if you just look at everything on the right side, and it's kind of similar idea that Roy talked about, right? Which is that on the right side, let's just say we only collect everything on the right side, right? So left side, whatever, and then right side we have oh, and then this is O of 1. Oh, so we do that, and then what's the left side? Left side is, well, just the input, right? So we're just kind of additioning them together, but with an XOR add, if you will, bitwise. Right? So we have this formula, we do it all together. But note that on the right side, as we know, you kind of just rejiggle it a little bit. I mean, not even have to, really. This is all 0, and of course the O. Oh, I have a typo actually. Yeah, so this on the right side is actually 0. So that means that on the left side, this would have to be 0. Is that always true? Is that sufficient? I mean, it's necessary, but is it sufficient? I think, right? Necessary being that this needs to be true for this to have an answer. Because if that's not true, then you just have a contradiction, right? Like, because this always has to be is necessary. But the sufficient clause is that if this thing is 0, does this mean this is good, right? The input is good. I don't know how to answer that one, honestly. If the XOR of these four things are 0, does that mean that there's always a solution? Is there even a way to find it? Well, I guess, yeah, I guess this is always true, right? Because that means that there are at most. Because I think, am I lying? I don't know. Maybe I am. Because these are known values. Let's say that both line 9 and 10 are true. So then, yeah, then O of 0, let's just say is equal to 1 without loss of generality. What does this mean, right? If, or just 0, just because it's a little bit more generic, maybe. Right? That means that then, now, D sub 0 is equal to O sub 0 or 1, right? And as a result of this, well, we know what D sub 0 is, we know what O sub 0 is, so that means that O of 1 can be one thing, right? It's just, you just do the formula. So then this leads to O of 1 is equal to O of 0, D0, right? And then now we solve for this, and we do, because it's just a calculation, then now you could look at the second formula, right? And this is in a very similar and inductive way. Well, we know what this is because it's just what we just calculated. So that means that, yeah, everything is forced. So I think that's a sufficient proof. And of course, the only nuance is that there are only two cases for every possible thing, right? Which is that the first digit is either a 0 or a 1, right? And then everything else has to be just follow through. And the only thing that may, so the one thing that may create a contradiction is maybe like 3D is because then now you have a formula with 3 variables, if you will, but they're all filled out, and that means that this can only be either true or false, right? And by definition of probably here, if you just do the math out again, then this has to be 0, so then this is probably true as a result. And I think maybe that is sufficient. Okay. I mean, we haven't written that much code yet. This is clearly a tricky problem, especially even with me, someone who has practiced a lot. So yeah, but all we have to do now then is just XOR everything. Yeah. I want to write X again, but that's why I'm like C per current. If X is equal to choose, okay, right, something like that. Oh, derived. Oops. I think I typed it, but I need to reset Firefox. Firefox just like drains my my memory or whatever. But yeah, okay. I mean, it looks okay, right? So yeah, so that's really the idea. The solution is very easy to like. It's rather, it's very easy to look at this and be like, oh, it's easy because it's like 3 lines of code, maybe even 1 line if someone tries, look smart or whatever. But the logic is obviously very difficult to kind of at least prove, right? You can maybe make some reason to it, but I hope that this kind of makes sense. Yeah, and I would say that even without all this proof, I think what I said in the second part actually that should have been the idea first, honestly, which I was kind of today, maybe just a little bit slower on. And what I mean by that is just that you can just guess. There are only 2 possible states to O sub 0, right? It's either 0 or 1, and it's just going to be linear, right? Like if you know what this is, and and this is the input, then everything else just is just like it has to, like. Everything follows through in a linear time because you just go one at a time, and so you should be able to calculate this anyway. And then it's just about seeing whether there's a contradiction at the end. Which, yeah, I mean, I don't know that, and I think in this problem you don't even have to show, because I think if it's not true, it's not going to be true for both of them, and if it's true, it's going to be true for both of them being either 0 or 1. Though the good thing is that you don't have to prove that. If you had just like did this thing, what did I do last time? Was I smarter last time? Maybe I should watch my video. Oh, it's only a year ago, a year and a half ago. I mean, this is basically what I did, I suppose. Actually, this is exactly what I did. So last time around, which is this idea of guessing the initial value being 0 or 1 and then just do the math out. And of course, but yeah, either way, this is linear time, right? And constant E space. I say E because, you know, you can say maybe it's O or B, where B is the number of bits or something. But yeah, that is all I have for this one, though. That's all I have. Thanks for watching. Stay good, stay healthy, do your mental health. I'll see y'all later and take care. Bye bye.